Should be sent out by, okay, looks good. Hopefully by the end of this weekend, or if not by this Monday. Okay. So let's get started. Where is the thingamajig? There we go. Okay. So I'm gonna start. This was I think a past exam for Lord. Exam 2. This was from 2012. We're doing this one. So just as a heads up, I took 212 with Akinlar. I never took it with Lord. So I'm not 100% sure about a lot of the stuff. So I'm just gonna go over things that I'm more comfortable with, like linked list, which we'll be doing first. So pretty neat. Everyone can hear me, right? You guys can see my screen. You guys can hear me.
Yeah.
Yes, could you read English? I'm really weak on it. It's like I'm having trouble understanding this.
We'll go over it. If you guys have any other questions, feel free to send them in the chat. Ooh, why am I talking to the waiting participants? No one's in there. Oopsies. But yeah, we'll go over linked lists. I'm gonna do that right now. I'll go for the first hour, an hour, a few minutes, and afterwards, we'll let Mike take over. So yeah. Anyways, so let's get started. So here we have string node, data next. Data is null. This is a constructor for it. Okay, sounds good. Public class string list, string node first, last length. Okay. Fill in the missing code for the constructor of this singly linked list, which has a head node. Okay. I'm assuming here he wants first to be the head. So the language is a bit confusing. Usually they say so in the linked list, let's draw a little linked list right here. Right. Okay. The first node in a linked list is usually called a head, and here he calls it first. So I'm thinking head is assuming first. And then the last one is usually the tail. Okay, so this is head. This is the tail. Okay. So let's fill this out. Okie dokie. So when we declare the linked list, string list, first of all, let's get the easy part over with. When we first construct it, what would be the length of the string list?
0.
0. Okay. Spelled length wrong. I think a bunch of you have memory from the last review, so if I do make mistakes, please feel free to
Would you question? I have a question.
Mhm.
Would you start off with the dummy node? Like if it's possible to start with just a dummy node if you like for like as a place starter, right? Like a dummy node, like string node n equals new string node, in parentheses with null. But does that work as well?
That works. I think that's how Lord does it, right?
Yeah.
He uses a dummy node so that it'll be a string node, say null is equal to new string node, right? And then he would set this equal to first is equal to null. Is this what he would do?
In the way I remember from the way Justin taught it, like I was reviewing Justin's review session, he said string node n is equal new string node, and then puts in for the parentheses null, first would be equal to n. So kind of like the same way you did it.
Oh, okay. So instead of, because here we don't, the reason why we don't put anything in the parentheses is because you see here in the constructor, we already have a constructor for when it's empty. So it already sets it equal to null.
Okay. Okay. Thank you.
So if this is how Lord does it, like I said, I never took Lord. I would stick to how he does it. So if this is how he does it, by all means.
Suleiman,
What's popping?
just one question. Using null as a string node name, wouldn't that be a problem in Java? Because it's a keyword.
Oh no, you're right. Shoot, my bad.
Yeah.
Why'd I put no? I meant node. I'm sorry.
Oh, okay, okay. And are you okay with us calling out, or would you like us to like?
Yeah, that's perfectly fine.
Okay, thank you.
Thank you. Like I said, I'm gonna make a ton of mistakes, so feel free to correct me at all possible moments.
Also one other correction. After string node, you put node twice, but then it's you can just put it as n.
Okay. Good. This is equal to n. I'm sorry. I don't know. It's been a long weekend studying for exams. Anyways. So this is the way Lord does it with the dummy node. So let's just actually do a dummy. Why not? The name doesn't matter. The string node dummy equals new string node. We're using the empty constructor here. So it's automatically gonna, what's right here? Right here. So it's automatically gonna say it equals a null. So right now, let's just draw out how this will look. Also, like we mentioned before, we would just set length is equal to 0. I think this is it for that's it for the constructor. Okay, let's just draw this out so you guys can see. So right now we created a new node. This is our new node. This is a dummy node, right? So this is here. And then we just set this equal to first. Wait a minute. Should we also add tail last equal to this? I'm thinking we do.
I mean, yeah, in the answer sheet, I think he put in last. So
Okay. Yeah, we would also set last equal to this. So this just creates a dummy node right here. There's nothing actually inside of it, that's why it's null, but okay. Also, for those of you who are confused, this little symbol right here, this just means null. This is the next pointer, and when it's pointing down like this just means the next is null. Okay. Anyone have any questions or see any mistakes with the constructor?
I have a question.
What's up?
Can you directly do this like first equal to null and last equal to null and length is 0?
First equal to null length. You could. That's also perfectly fine in my opinion. But I think when it comes to Lord, he usually uses the method using the dummy node. But yes, it is possible to say like first equals null, last equals null, length is equal to 0. That's an alternate way. But this is like Lord's way. It's the way of the Lord. Right. Way of Lord. Yes, he usually uses a dummy node. But either way works. Okay. Way of Lord. Any other questions? I'm taking this out as a yes. All right, so next part. Fill in the missing code for the method prepend, which should add a new node to the beginning of the list, not a new head node. The new node should contain the data given as the parameter. Okay, so let's get cracking. So first thing, what do we do? Let's create a new node using the parameter. So you would do string node, it's new. Let's name it whatever. I like naming it nodes. Like when you do use when you use linked lists a lot of the times, you don't really want to think of new names for each variable, so you just use the same node, current, etc. So it's a new string node. We would pass in value. Sorry. Okay. Oops. All right. Good. Oh. Okay. And then let's see. Well, we would check. Let's see. So right now we got to think of two cases. See two cases. The first case is this case right here. If there's nothing in the linked list initially, right? So that would be the first case. And like I said, and I didn't say that actually, but there are multiple ways of doing this, but which are correct. This is how I'm going to do it. So we're gonna check if length is 0, right? What does that mean? That means we're in this scenario, where it's empty. Which in that case we would just this is our new node, and this is a linked list right now. It's a dummy pointer. It's null. We have this new node right here. This is our new node, whatever value is inside of it. We want to prepend it to the beginning. Prepend, yes, beginning. So we want to move this here. Okay. And remember, this new node also has a pointer. And oops, I got it. Last equals first. I'm assuming that's for the last question. Are you talking about this question, Krishan? Because in this case, if you say like last equals first as well, that also works. This is fine. Okay. Since first is also dummy. So let me keep the chat here so I don't miss out on your questions. Okay, so we have this new node, we have its pointer, we want to make it, we want to attach it to the end. And this is if its length is 0. So if the length is 0, what do? We set the new pointer node dot next is equal to first. Okay. I think that's it for that. If the case is that it's node dot next is equal to first, or actually would there be actually yeah, that avoids it. It doesn't matter because it's a dummy node. Okay, I see. So this is a new node right here. And basically we want to add it to the end. So we want to put it here. The whole idea of linked list is if you adjust the pointers, that's like pretty much it when it comes to linked list, because the pointer is what allows you to traverse through it. So if we are able to change this pointer from pointing here to here, right? Then that would basically, in a sense, prepend it to the list. So in essence, what we would do node dot next is equal to first. Okay. And now, wait, let me draw this. This is first. And remember, this is an empty list in this scenario. This is also last, right? So that means we also have to adjust where the first pointer is pointing at. So this would mean we would have to move this here. Okay, so then we would just say first is equals to node. Okay. And then we would increase the length. Equal to length plus 1. I think that's it. Let me just make sure. Does anyone have any questions about what we did?
Just a question about the length variable.
Mhm.
We have it initialized inside the class, right? So that's why we're able to access it.
Yes, it's right here.
Okay, yeah,
These three things, because they're initialized in here, we could use them.
got it.
Okay, I think someone said anything in the chat.
So I have one question.
Uh-huh.
So what about the dummy node? Like I think like dummy node is there should be a dummy always a dummy node. That being said, is it node dot next should be same as first dot node and then first is the next?
Hmm.
Like since we defining first as a dummy node, when we say a node dot next is a dummy node, we are pointing first we are pointing to a dummy node.
Okay. So first we're
So
pointing to our dummy node, okay.
so like when we say node dot next is equal to first, we are pointing what do you call that node next node after node is a first which is dummy node. So is it, I feel like it's kind of wrong.
Well, the idea here is because it's prepend, we're attaching it to the beginning of the linked list. This is why I don't like using dummy nodes. It makes things very weird. But
Or even it's a prepend, it should be like after a domino, isn't it should be after a domino. So when look at the solution, it says node dot next is equal to first add node, and first add node is equal to node. So like we are inserting after a domino. That's what basically the solution shows, and
oh,
I
I
feel
see what you
like.
mean. So it's like, let me just draw down and see what you mean. So like say this is the first, right? This is a dummy node. Right here we got the linked list, dot, dot, dot. This is the first. So you're saying this is a dummy node right here. Any new node we add, it has to be like after the dummy node, so right here.
Yes.
Oh, okay, that switches it up. My fault. So in order to do that, what we could do length is equal to length plus 1. Yeah, I see what you're talking about. This is why I don't like using dummy nodes. It makes things very annoying. So the idea is instead of adding this node to the very beginning, we also have to remember that since we're using a method with a dummy node, we have to keep track that everything after a dummy node, like this is where the linked list starts in essence, right? We don't want it to start from here. So in order to do that, what we do is basically adjust the pointers. Right now, this is first, so we do first dot next is the node. Okay, I think that's correct. Wait, no, sorry. We would first have to adjust. Okay, this is the order of the pointers. So we have the new node here.
So
Oops.
what I'm saying is node.next is same as the pointer at first.next. So we're
Yeah.
gonna say node.next is equal to first.next. Then we replace first.next is equal to node.
I'll just type down what you said. So first, no, sorry. Node.next is equal to first.next. Right, so this is basically taking this node pointer, this one right here, and moving it, pointing it towards what the first pointer is pointing towards next. Right, so this is going to point towards here, which in this case, if there's nothing in it, this, let me erase these pointers, would then point to null, right? So this would also point here. And then we would adjust this pointer, the one coming out of the first node, which is the dummy node in this case. This would then adjust here. In this case, it would be like this. Okay. So that would look like it would look like this. So then node.next is equal to first.next. First is equal to no, not I'm sorry. First.next is equal to no. Okay. Someone said something in the chat. Just making sure this is correct. If first is equal to last, last is equal to n. Okay, yeah. You gotta think of one more thing, which is the case here. So this takes care of this case. So this is good for this case, where like the first node and the last node aren't the same, right? But if they are the same node, right? So in this case right here, let's redraw it right here. If the first and last are the same node, right? And we add a new node right here. Right, it's the new node added. We've just moved this. First stays the same. This goes here. We have to then move the last pointer from here to here, right? Which doesn't matter if it's like we're this, how do I rephrase this? If the case is that we have multiple nodes, right? Like this, dot, 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 right? We could just add it here and then we wouldn't have to worry about the nodes later on. But because in this case, right, initially it was empty, right? We would then have to adjust the last pointer whenever we add a new node at the end. I mean, a new node in the beginning. So this is why we have this extra case. Let me erase this right here. If first equals last, and last is equal to no. And that's it. Does anyone have any questions about this? This method?
Can you explain it one more time?
Can I explain it one more time? Sure. Okay. So this first line is basically taking whatever the value is we pass in, and we're creating a new node for it. So let's say this is, let me redraw it. This will make a better example. Right. So this first line creates a new node with our value. Right. Initially, this is how it's created. Boom. Okay. And when we have to add this, remember this is prepend. So this is adding to the beginning. And I think I forgot who brought it up, but that was very important that I brought it up. Remember, when we initially have our linked list, the first node is always a null node. So this is a null. Let me put an N for null, yeah. And yeah, that works out good. Okay. So we basically want to add this node, new node right here, right after the null node. And this would be like the new beginning of the list. Okay. And in order to do that, we have two cases. The first case is like if the list has like more than one thing in it. So like say something like this. All right, let's go ... Then the idea is we just have to adjust the pointers. So we say the node.next is equal to first.next. So this pointer points here, right? And now we adjust the first pointer from here. Sorry, no, this is first. So you adjust this pointer from there to here. Right? So it's kind of like squeezing in the beginning. Right?
This is the
This is these two lines. What this is basically doing. Right? This is this. But we also have a corner case where what if the list we are inserting into is initially empty? If it's empty, then what does that mean? Someone's saying something in the chat. I gotta keep that open. Wouldn't first always be equal to last? Don't you need dot equals method? No, dot equals method. I don't think we need it here. Because dot equals is for strings. If it's emptied, is it your first also last? Yeah. So if it's empty like this one, then our first. Okay. Then our first pointer and our last pointer are both pointing towards the same thing. So that's where we have to adjust it. Because right now, these first two lines, they do what we want it to do. So it's basically taking a new node. It's this is the new node V, right? And then this is basically saying this is V. So this node.next is equal to first.next, which in this case, since first is this pointer, first.next is null. So the new node.next is also going to be null. And then it adjusts first.next is equal to node. So then this is going to be like this, right? But we also have to adjust the last pointer now because now that we added the node, this is no longer our last node. So which in this case, we have to use this portion right here. This is important because then this says that you basically change the last pointer to pointing here. So now this is last. Okay. Is everyone good with this? Any questions? I will take this silence as a yes. Does anyone in the chat have any questions? Could you simplify? Yes, you could do that. Yeah. Sorry, I also held a C++, not C++, a 111 review, and they weren't 100% sure on this notation, so I guess, yeah. You can do lang++, that's fine. Okie dokie. So is it better to remember the second one instead of the first? What do you mean by that? Jaden. Also, someone gonna speak in the chat. Sorry if I cut you off.
No, I just wanted to say, so in the fourth line, the second to
Mhm.
last line, we're basically saying that if it's the corner case where the first is the last node, like the dummy node, basically, just
Mhm.
make that new node a starting position, and then from then on, it's gonna prepend behind that, right?
Yes, basically this last one is saying that if, like you said, they're both the same, the dummy node,
Mhm.
that means the first and the last node are the same thing. So once we add a node, that new node we just added, this becomes a new last node in the
Okay.
same way.
Got it. Thank you.
All right. Any other questions? Okay, you guys can agree with Ivan for 111, but okay, I'll let you do that in the chat. Anywho, so write equals method for the linked list class. There's a lot of typos in here. String list. Class. Two lists are equal if they have the same length and the data of each corresponding node are equal. If you need more space, continue your answer on page 4. Page 4. Okay. I don't think we'll need much space, but okay, let's do this. So first things first, let's check the length. So what do we check? If. So this is, we're comparing this with another string list. So that would mean,
This and other.
yep. So that'll be this dot length is not equal to other dot length. What does that mean? That means they're not the same.
You just
Link.
return false.
Exactly.
Question.
Hmm.
Can you just use length instead of this dot length as well? Like, does that also work as well? Like, count as part of the if statement? Because he won't. I'm asking because if you won't take off points for like penalizing, if you're just using length.
In my opinion, that should work. Because I get what you're saying, since we're all already in like a specific class for a string list. But just to be safe, I would use this. Like what I think Kevin is saying. If we did length is on it, if we did this in essence, I think should still work. But just to be safe, it doesn't harm to add like this dot length.
Okay. Thank you.
All right, so that's the first thing. Okay, so this is a string. This is important. Okay, this is good. This is important. This had changed their answer. All right. So otherwise, we have to basically go through both of the string lists and see if every single thing in each list is equal. So how do we do that? Let's do pointers. So you'll do string node current 1 is equal to this dot first. Sorry, not first. Because both of them are first. No, sure.
I think
I'll
it's
do-
fine, right? Because they're both supposed to be, like the first node should be the same, like the dummy node, maybe, right?
Yeah, both of the string lists have a first node which is dummy. So it doesn't really make sense to compare the dummy nodes of both lists since they're both null. That's why we do current 1 is this dot first dot next.
Got it.
All right. And we do current 2. Like I said, you can rename these variables whatever you would like. So this would be other dot first dot next. Okay. So now we have our pointers. So, and also we know that because we're after this if statement that both of the sizes are equal, so we could just use one of them as the counter. So we'll do while current 1 is not equal to null. What do? We basically check if what was that?
Use an if statement that says like for cur1 if not cur1 dot data is dot equals. This is where you can use the dot equals method. In parentheses for cur2 dot data inside of the parentheses, and then
Yep.
just return false.
Yep, bingo. So this is basically checking is the data in current 1 if it's not equal to current 2, you return false. And the reason why we use dot equals is because, like I mentioned, the data is a string. Okay. Is everyone good with that?
Dot equals
Yep.
method is the string method, right?
Yes, dot equals is for the string. Is that your question?
Yeah.
All right. The audio is a bit fuzzy, but we'll make it through. Which in this case we go through each. Sorry. We also have to update the pointers. So we would do current 1 is equal to current 1 dot next, and current 2 is equal to current 2 dot next. Okay. And once we exit the loop, that means that we've went through, that means that first of all, the sizes are equal, so that's fine. And we went through each of the nodes and we saw that the data matches for each node. So what do? We use return true. All right, and that's our method. Make sure it's correct.
Wait, can you explain lines 2, 3 again? Like what does that mean?
These lines?
Yeah. Yeah.
So basically we have these two linked lists, right? So this is linked list 1 yada, yada, yada. And this is going to be linked list 2. Because we're dealing with linked lists, you can't really use like for loops. You always have to use like a while loop of some sort. And but let's say this is a dummy node for both. Okay. This is a dummy node. That means null. But basically what we're saying is in order to go through a linked list, you always have to use some sort of pointer or like a dummy pointer per se in order to like loop through each element. So here we're basically saying we're creating a first dummy pointer. This is current 1. That's pointing at the first element in the first linked list. So this is, let's say this is this. This is other. We don't really care about the null, the dummy pointers for both linked lists since they're both just null. So we can ignore those. And current 2 is going to be this. So this is current 2. And by having them, we can now go through the linked list one by one and compare each of the elements. Does that make sense?
Yeah, so he just wants us to use the dummy nodes. Like we don't have to use them, right? But he just wants us to. Like, is that it?
For these,
Yeah, like we have to use the dummy nodes, or is it just he just wants us to do it? What is it?
well, we had the dummy nodes in the constructor. Like I said, I never took Lord, but by what I'm hearing, I think he prefers that you use dummy nodes
Oh, all right.
using the linked lists. So yeah, I would stick with the dummy nodes. You don't really need to use them, but yeah, for Lord, I would stick with them.
And that's what you're doing for like the last few lines too, right? Like the current one equals current one dot next, that those lines.
Yeah,
That's the same thing you're doing.
these lines are just comparing the data. So this data is equal to this data, this one's equal to this is equal to this, etc. And if they're not equal, that means they're not the same list, and we could just return false. So that's what this is doing.
Oh, all right, but
Okay. And yeah. Is everyone good with these methods? I refuse to do the GUI. Never learned it. Everyone good? Justin is a goat. I don't think he is going to replace. He's going to, where is he going? Going to Bloomberg. Going back to Bloomberg. He's going to a better place. Explain if statement again of this portion, Cozy. This one right here.
Oh, yes.
Okay. The idea is, right, so now we have these two nodes, not nodes, we have these two pointers that go through each linked list, right? And the idea is if we have like say the current one is here and current 2 is here, right? Say this is string A, B, C. I don't know, let's say this is string A, B, D, right? We're basically comparing the data in each node, like each corresponding current node, right? If they're not the same, right? So here this is ABC, ABD, these are not the same, the data is not the same. That means that these two lists aren't the same either. So we could just immediately return false, right? Otherwise, we just move on to the next node and compare that. That makes sense? That's the whole idea of the current. If we see two current nodes that aren't the same, then we could just return false right there. Okay. So anyone have any other questions about this question in particular?
No, I
Um,
think
oh, sorry.
Go ahead, go ahead.
no, I when I was looking through this problem, I felt like I was looking through the old video, like old review practice sessions that Justin had, and no, those really helped. Those really freaking helped. Thank God.
Justin is the GOAT. That's why he's going to Bloomberg, man. That's not everyone gets into Bloomberg. But he's going to a better place. If only we could keep him here forever. I don't think we have in the budget, Mike, to keep Mike here forever, to keep Justin here forever. Anywho, Is sorry, what was that?
Not a question in particular to this, but what if there was a compare to method? Like I just want to understand the return idea with -1, 0, and 1. I know that -1 meaning less than, 0 meaning equal,
Mhm.
1 being greater. But in this case, is there a way to maybe apply it here if we needed to?
Well, I think does Java have a string compare to method? You would have to, in order to do the compare to method, because I get what you're trying to say. In this scenario, you would basically have to see because it's difficult to like judge what counts as less than or greater than when it comes to strings, right? Is it like are you talking about length? Or are you talking about
Oh yeah. No, that makes sense. I was just thinking about our project, because we at one point we had to make a compare to method, so I was just wondering about that. But that makes sense. Never mind.
Yeah,
Yeah.
because like compared to it really like it makes more sense when it comes to like values like that can be actually compared with one another. Like with strings, you have to like define certain criteria in order to compare them. So
Yeah.
okay. Alrighty. So if no one has any other questions about this, do you want me to do is there a linked list question here? Linked list. What is this? Implements exam 2.
I think this is event programming.
Oh, assume that sync security numbers created correctly. Write a method for this that will print each the list to the system console. You guys want me to do this question real quick? One more linked list question, or move on to something else?
Yeah, that would be great.
All right, let's do one more linked list question. Okay, so this one's not too bad in that we're assuming that a singly linked list with head node containing social security numbers, as in lecture on dynamic structures, has been created correctly. Write a method for the social security number list class will print each social security number in to the system console. Okie dokie. So let's do this. Also, if anyone who came in late, get answer and get string need to be declared. What are you talking about, Ivan, for this one? Or for well, here we don't need to declare those. That's
No, no,
fine.
no. I think he meant for the question you were talking about earlier. Not this one. We are the one yeah, this one for linked list. Or
Assuming
The
that
second question.
the second question. Yeah, sorry, interface.
Oh, this one. I'm not doing this one. I'm doing this one. Mike can do interfaces. I'll let him get tortured with that. Here, wait. Yeah, we do that later. But we're talking about this question. I think Ivan, do you have any questions about this one? This question in particular? No worries, brother. Nah, it's not messed up. Mike took Lord. I never took Lord. I have no idea what Lord wants to ask what he's. I've seen like your projects that you guys are been working on. Thank God I didn't take Lord. Anywho, let's write the method. So that will print each. Okay, so let's do this method. So let's do public. Let's say void.
Print SSNs.
Sure. Print SSNs. Yeah, I got very lucky with that one. The goat 212. It was the easiest A in my life. SSNs. This would be we're gonna take in. I don't think this is gonna be in the list. Okay, so this is gonna be we don't have any parameters for it, so this would just be a method in it. Okay. What do we do? First, dummy pointer. So we would do. I'm just assuming. Let's say SSN node is equal to current. Where can I find this practice exam? I can't find it on Brightspace. Mike, are we able to share the practice exams to the students
I think it is like you all have to assess the practice exam. So because I Lord doesn't change, so this is our like practice exam, but it's the same. So like you should be able to find it.
Okay.
It should be under the contents exam folder. Yeah, as Jaden said.
Yeah, it's under the exam content.
Sounds good. Sounds good. Well, let's continue. So first, we have the current point. We have the current pointer. Oops, sorry, this is not. Sorry. So this dot head, right? We don't need that. We just said head, right? So with head node containing social security numbers, I'm gonna assume he doesn't use dummy pointers in this question. Which if he okay, let's just do this real quickly. Yeah. Head dot next if dummy pointer. Right? So if he does use a dummy pointer, I'm not 100% sure how he did this question. This was an old exam. But if he did use a dummy pointer, we would just use head dot next instead of just head. Okay. And this is where we loop. So while current is not equal to null, what do we do? We just print out system dot out dot print current dot, let's just say SSN. Am I right?
Current
Just
data.
fix it. What was that?
Would it be current data?
Well, the thing with this, because over here he like explicitly writes out the string node and string node data, right? Here we don't really know what, because he says assuming that yada 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 has been created.
Okay.
We don't really know what it's called, so I'm just gonna put current dot social. Or we can just put current dot data as well. It doesn't really matter, right? And then we would just do current is equal to current dot next. And I think that's it. And I'll print head method social security number list class with print each social security number in the list to the system console. Let me just make sure that's correct. It looks correct. Yeah, pretty much it. And if you want to generalize it for just any list, you just do, let's say we have SSN list. This would then just be list, I'm sorry. List dot head, list dot head next. If yeah. This one's a very weird question.
I have a question.
Mm-hmm.
So does it only says just print the SSN numbers or including the class of SSN list, like declaring the head and doing everything so far until we print the SSN list?
What do you mean? Over in this question is just telling us to write a method that'll just go through the list and print out each social security SSN. That's basically it.
Oh, okay. Thank you.
Mm-hmm. That's why I'm saying like this isn't too bad. Okay. It wasn't bad. Anyone have any questions? Well, let's see what else we can do. I'll leave this mic as well. Is there anyone I could do? Let's do this. Actually, Mike, do you want to take over? Because you never,
Yeah, sure.
like, what is this? What is this foreign language to me? What the fuck is this? Can you go back to SSN list? Right here. Okay. All good? Any questions about this? Okay. All right, so if that's the case,
All it's doing is going through the list and printing it out, right?
yes, this is, who asked that question? Sorry, Tanjila. Yeah, this is basically just going through, you have a dummy pointer and you're going through each specific node in the list and printing out the information. That's it. All right, so if no one has any other questions, I'm going to, why did I unmute myself? I'm going to stop sharing. I'll let Mike take over. I'll still be in the chat. So if anyone has any questions, I'll be sure to try and answer, and I'll also try and, damn, you guys are really talking about this random stuff in the chat. Okay, fine. All right, take it away, Mike. Mike, are you talking right now?
Oh yeah, I'm talking and I'm muted. So yeah. Okay.
Good.
So are you guys going to go through the problem that will be on the test? All right. This will be on the test, like 80%. Very similar. So yeah. So this is a output question. It's an easy one. So you have array. Wait, do you have any other questions or any other problem that you guys want to do first?
I think this will be a good one to start with.
Okay, let's go. All right. So yeah, so he will give you an array, and then there's a loop. Make sure it start from. Make sure you know it start from -1. So okay, and then you go to next line. Try. Okay, you try, and then you try to print it. The answer is, okay, you try to change. So integer the first in min. It change the string to integer, and then plus the element. So ident I. So ident I is -1. Can you get negative index in
No.
Java? No.
No. No.
So, is it going to give you a number format exception?
No.
No.
No. Is it going to give array index out of bound?
Yeah.
Yes.
Yes. So it will print this line. So it's going to print. Oops.
No.
And then ident I
not that
is.
one.
Oh,
Battery.
sorry.
Battery.
Battery.
Yeah.
Battery. My bad. So it will be battery. Right? And then I plus plus. Wait, before that, there's a finally. So finally mean every time you do try or cache, you need to run this line every time. So it will be, let's go. And then you go back to the loop. Okay, now I become 0. And then again, you try to print out. The answer is integer first in ident I. So ident index 0 is this one. So 10. Yes, 10 is like a string, but it's a number, so I can convert using integer the first in. So this 10 will not give you any error. It will convert to number 10. So it will print this line. So it will be like this. The answer is 10. All right. Yes, finally always print every iteration, correct? And then, so we're gonna do, let's go. And then, okay, now I has become 1. So index 1 is exam. So can you convert exam to the number?
No. Unfortunately,
Oh.
it falls under no, NFE for the catch.
Yeah, it will give you a number format exception because you cannot convert to string to the number. So it will be like this. Oops. And then item I is exam. All right. And then I become 2. This is 20. So you can convert.
Don't we say
Oh.
let's go?
By the way, there's finally. So let's go again. My bad. So there will be let's go every time, every iteration. And then you go to another iteration. I became 2. So 2 is 20. So you can convert. And that will be the answer is 20. And then again, finally. So let's go. And then and the iteration 5. So here is ident.length. So we don't need to worry about like index out of bound again. So it will be still like ends at 5 here. So 5 you cannot, oops, sorry. So you cannot convert. 5 you cannot convert. So it will give you an error. The error will be number format exception because you cannot convert string to integer. So it will be oops. And then 5. Now finally, let's go. All right. So I think like somebody asked me, let's go is not in the solution, but like we need to add the let's go in the end. All right. Any question?
I have a question.
Okay.
So, which one would fall under exception E? Like, oh no.
If it is not number format exception or if it's not index out of bound, we print this line. Okay.
I mean, can you give me an example, like what can be?
So the example will be, let's say,
Perhaps maybe in the try block there was another thing besides an index or a number format. Maybe that error would go into that exception, right?
what do you mean?
Like besides this in the try block, we have only one line of code. If we had a second line with some other sort of statement that didn't involve index arrays or arrays indices or number formatting, and if it was an error, then
yeah.
that would fall under, right?
Yeah. For example, like one of the obvious example is if he doesn't give this line, if he doesn't give like this line. Okay. So there's no index out of bound. So you need to, okay, you find index out of bound, but you cannot find it. Right? So you need to go to this line. Oops, because I cannot find the relevant error statement. So this exception is like a general statement. Right? So in this example, like if he doesn't give you like one of the number format exception or the array index out of bound exception, you need to do this line. All right. Sounds good.
Yeah, thank you.
So I cannot speak this one. Can you guys look in the chat? Yeah, so I will go over something in the end. So yeah, I have my test, so I will do in the end. So yeah, before that, let's do the review sheet first. Okay, sounds good, guys. Do you see in the chat?
Mm-hmm.
Good. Okay. All right. Any question with this?
No, I don't think so.
Okay.
It's all good.
It's all good. Well, someone asked me to do all things again. So, by the way, Suleiman, hello.
Hello.
I think we have a breakout room, right?
We do have breakout room?
Yeah. Can you, I think, okay, I will give you the student name so you can, like axiom to
go.
try, and then you can do like review the same question again, because I don't want to do the same question again since
Okay.
I majority want to move on. So
Sound good. I mean,
can you like do one-on-one with her or him in the breakout room?
does anyone want to go over this question one more time? You just say it in the chat. I'll add you to the breakout room.
Do you know how to do it? Do you know how to do breakout room, Suleiman?
Yes.
Okay, thank
I
you.
will learn. So anyone else? Okay.
Yeah, so anyone who want to go over this question again, you can join the breakout room with the Suleiman. So he will go over this again.
Anyone else?
All right. So I think did you open the breakout room, or should I open the breakout room? Oh, he opened the breakout room. Yeah. So if anyone want to do, you can join the breakout room. Otherwise, you can stay here to move on next question.
If anyone else wants to go over this question and join the breakout room, feel free to let Mike know. He'll assign you to the breakout room. Yeah.
Sounds good. All right. Let's move to next question. Okay. So this is also the question that also acts in my exam. It is very similar. He changed very little bit, like just like maybe he changed about like this extends to like not alpha something else, something like that, or he might change some numbers here and some other class name or something like that, but it will be very similar. So this is a question about inheritance. Okay. So you have an array. So this makes array like has a place of 4 place. So 0, 1, 2, 3. So the data type is alpha. So it can hold the class of alpha, right? Okay. So and then we create an object. So this is a recurrent object, put into the first index place, put into the second index place, put in the third, put in the fourth index place. Okay. So don't confuse with like this new and this new. Okay. This new is making an array. This new is making an object. All right. So let's see. So I create an object of beta. So beta is here. Since beta extends the alpha, so it will be like this. Alpha is here. The beta extend the alpha. Beta is here. Gamma is also extend the gamma is also extend the alpha. So gamma is here. All right. So which means beta is like a child of alpha. So beta inherit all of the alpha properties. All right. Okay. So once you create an object, once you run this line, it will go to here. It will do the constructor first. So the constructor will be receive the y value. So the y is 1. So y is 1 here. Let me write it again. So y is 1 here. And then we go to this line. Okay, it is like super, but pass the y plus 3. This one stay 1, right? 1 second. So this one is stay 1. This y plus 3 is 4. So super, what does super do? How do you understand?
Super is like inheritor. It inherits the class.
So it is, you can say like that, but like the easiest term is it call the parent constructor, right?
Yeah, like
it only call the parent constructor. So when you see the super, go to the parent constructor. Parent constructor is alpha, so go to alpha class, and then receive the x. So it passes the values of 4 because 1 plus 3 is 4, and then it call the super again. However, alpha doesn't have a parent class, so this super will not do anything. All right, and then it just print this line. I'm alpha and x is 4. So let's write here I am alpha and x is 4. All right, and then after I print it, it is then here. So it goes back to the beta constructor. So the super is finished. Then next line is here. I'm beta is y is
Y
what?
is going to be 1.
Y is going to be 1, right? So I am beta and y is 1, right? Y is not 4, all right? So this is, I just add it and pass to the constructor. It doesn't change the y value. Y value is here. Since you don't see, if you don't see like y equal to 1 plus 3, so if you see this, it change the value. If you don't see, the y value doesn't change, right? Because it just passed to the constructor, to the like super constructor. All right, and then you're done. So this line is done, and then you're done. So you're finished. So in this place, you have an object with the better value of 1. All right, let me delete this again. Okay, now let's go to the next slide. Next slide. We do the beater. Okay. Again, the same thing, only the value change. So I will speed a little bit up. So y is 3, 3 plus 3 is 6. Go to here, x is 6, and I'm alpha and x is
6.
And then when you're done, you go back here, this line, and then it print I am beta and y is
Y is 3.
Yep, y is 3. I'm beta and y is 3. All right. Okay, after you're done, this line is done. In this array, it will be beta with the 3. All right. Okay, so now you're done with the 2 beta. Let's go to gamma. It's the same thing. It's just repeating 5. So go to this line, y receive 5. Super 5 plus 5. And then do it again. I am gamma. Oops, sorry, my bad. It goes to super first. So go to super. So parent is alpha. So let's go to alpha here. 5 plus 5, it will be 10. All right, and then it will print this line.
Wouldn't it be 10 plus 3 since we're going into beta super first? No.
So no, we are in gamma.
Oh, it extends alpha, not beta. Never mind.
Yeah, gamma with number 5. So it will be 5 plus 5, 10. And then I am alpha. And x is 10. Since I finished, I will go back here. And I am gamma and y is 5. Okay, all right, what every and compiling error since there is no extension for in the class. Yeah, so this one it called it, but there's no parent, so it will do nothing. It will not give you an error. It will just do nothing. Right? Sounds good. All right, good, nice. So one last thing again. So before that, I put it here. Gamma with the value of 5. And then here's number 3, array in place 3. So gamma 7. So 7 here. Let me delete again. So it will goes here. Y became 7. 7 plus 5, 12. Super. Go here. So it will be 12. So x is 12. And I'm alpha and x is 12. Okay. And then finish it, go back here, and I'm gamma. And y is 7. Right, sounds good. Any question?
I'd like to know one thing.
All right.
So can it be like chained, like gamma extends beta, beta extend alpha, like the super class?
Gamma extend what?
Like can it be chained like gamma extends beta,
Yes,
beta extends
yes. In the test, he can change. This can be anything. This can be anything. Like it can be beta extend alpha and gamma extends to beta. Right. So when you call the super, you go to here. You go to here. You need to call the super twice if gamma extend beta. Right. Gamma extend beta and beta extend alpha. Would you have to do the super twice? Yes, you have to do super twice. Yes.
So I mean, if the gamma extends beta, so it gonna go to directly to the super class of beta, or like the starting from the beginning, like
So okay. Let's do that. Let's do that. Okay. Let's do that scenario. All right. So gamma extends to the beta. Right. So this is beta. Let me do another. So this call. Okay. Let's just see the another the last line 7. Right. So goes here. Y receives 7. And then super 7 plus 5, 12. It goes to here. This constructor. And the y became what? This y became what value?
is it 12?
It became 12. And then 12 receive 12 is y is 12. 12 plus 3 is 15. Go to here. All right. It goes to this parent. X became this x became what value?
15.
15. Correct. And then it's called the super, but like since we don't have any parents, we ignore it. This will print I'm alpha and x is 15. After that, it's go back here and I'm beta and y is 12. And then after that, I go back here and I'm gamma and y is 7. So it will print like extra more statements. Good.
Thanks for the clarifying.
Right. No problem. Yeah. Okay. I mean, do you guys want to see my old questions? Or do you guys want to see this later? Should we do another problem first?
Yes, please.
Why? How do you see Ender? Oh my god! I should have deleted. All right. So for the GUI, no, I mean, for the GUI, so lately, the Lord doesn't like ask you GUI, So he asks you that about like more like this, more like do you understand the material? For example, I believe you have learned the tree map, right? Do you guys know tree map? Yeah, okay. So he will ask you about, okay, what is different between hash map and tree map, right? So you need to explain, okay, so tree map is like it's order. Yeah, tree map is a hash map with order. So yeah, so hash map, in the time complexity way, in the time complexity, the hash map is more faster, and tree map is like not faster. Yes, he acts generic in my test, the generic too. Yeah, and then he asks about like how about array list and linked list? What's the difference between? Do you want to go? Okay, let me ask you. Do you want to go GUI or the other questions that I have?
GUI would be fine, I believe. I'm not sure actually what others.
I mean, okay, let's just do one GUI and let's do the other question. Sounds good? We have time, yes. So let's do one GUI, just one GUI. Okay, GUI is just memorize. You just memorize in a test, boom, boom, boom. That's it. Okay, what GUI do you want to do? There are two GUI here. I mean, three GUI.
Can we do the first one?
This first one? Okay. All right. So this is so in your project, so in the project, okay, don't talk about the old questions too much, okay? Or I'll get trouble. All right. Just keep low. All right. I just do the review from the review sheet. Okay. Don't talk about like other special question. All right. All right. Okay. So here's class. It extends. Okay. So this is like if you do if you do the project, the last project, project 3, right? So if you guys doesn't use ChatGPT and you guys really study the lecture, you will understand this question, because like this question is basically from the lecture and from the project. And so so this is like a menu bar. We make like a menu bar in a GUI in the project. And then so with the GUI and stuff, right? So this is before you do the menu bar, you need to do something.
You'll
Alright.
need to for the first answer. I think it was JFrame.
There's already JFrame. You need to extend the JFrame. So like he doesn't like ask you in the project. It doesn't require to do the JFrame, but like in the test, okay, when you see the extends, you could do the JFrame. All right, and then private JFrame main window. Okay, main menu bar. Right. Okay. So this is the JFrame main window. What is the main menu bar?
Is that menu bar?
The menu bar. The answer is already here. All right. All right here.
So basically, your clue is just to keep your peepers open on like on the entire question. It'll just give you the entire answer. You just gotta write it on the answer sheet, right?
Yep.
What did it be? J menu bar? The actual title of the.
Oh yeah, sorry. Yeah, J menu bar. My bad. Yeah, it will be J menu bar. But like you don't need to like really memorize it. You can just do the menu bar. So 3 would be main menu.
Actually, no.
Yes.
Main menu. It's not main menu. It would be exam 2, I think.
Yeah, you mean the number 3? Okay, let's see. Let's see. So you can find the answer in below, right? You can find the answer in below. So let's see.
you look at the directions, it says it mentions exam 2 in the
Yeah.
top.
Yeah.
Yep. Yeah. Here.
No,
Because.
not there. If you go a little bit up.
But oh, you mean here?
No, more up. Where the
What?
directions are.
So in the question itself, it's in the context of the question. For at the answer for question 3, J menu, you put in exam 2, which I think that's how they they want you to put the out for the program. Private J menu exam 2.
Oh yeah. Yeah. It says J menu exam 2. Yeah. Okay. I was going to talk about like this line, but like, it should be fine. It's the same because here you create a J menu, so that is why in this J menu the variable name should be exam 2, right? You can find in the like in this method, right? And then okay, right. So this line give and pass and then fail. So it will be okay. So we don't since okay. So here and oh, now he doesn't give you. So like you need to know. So what should be in number 4? Yes, J menu item. So what you need to know is you need to know J frame. So J frame is the big thing, the biggest thing, and then J menu bar, and then J menu, and then J menu item. Right? So it's like a hierarchy step. All right. So it will be J menu item, and then what about number 5? And pass, fail, pass, fail. You can see and pass and fail, and M quick. Because of this, okay, I put M quick. Right? So you need to know like you need to read you should be able to read the code. Okay. It is JMenu item. Where I use JMenu item, I use it here. Since I use it here, there are 3 variable. So we need to like so this must be like 3 variable. I don't have like GUI question in my test, so I don't know like it will be GUI in the test, but like I think he will give you like this, so you need to fill the answer on the right side. If he acts like this, I don't know if he acts or not. The question won't ask you to create. No, he will not ask you to create whole GUI. It will be too much. So he will just give you code, fill in the blanks. Right? So it can be this one or it can be this one. So because this one is like action performs and stuff like that. So there will be like there's like 2 possible that he can ask. I think this is different one, but like, I think he will ask about like mostly about this and this. There's higher chance that he will ask that. But it should be easy. Should be fine. All right. Okay. So what about number 6? Is exam 2 ML. So let's find exam 2 ML here. So we found it here. Okay.
So would that be your listener?
Yep, it will be my listener. Right? It is very similar like action listener. Yep. So it will be exam 2 listener. Right? So like if you do the project, you should be familiar with these words, right? All right. Okay. Number 7. We already did it. What is it? What is it about these 3 variables? Yep, they are all JMU item. There's no S. Okay. I think there's no S. Just item. All right. Number 8. Okay. So menu bar. Create the J menu bar. And then menu bar at the what? Menu bar at the menu. So what is the menu? What is our menu? Our menu is exam 2. All right. All right. So menu bar at the menu at the menu item. So it will be like step by step. So okay. Let's look at number 9. All right. Number 9 is exam
This
2
is-
ML. Sorry.
So it's the same thing as number 6. It's exam 2 listener. So since it's ML.
Yep. So here, so new, we create an object of this exam 2 ML. Since exam 2 ML is exam 2 listener, so just exam 2 listener again. But since I am creating an object, I need to add a parentheses. And since action listener or the listener, we need to pass this. So this will pass your whole J frame to another class to do like J menu bar or something like that. When you click, do something. All right. Okay. So the last one. What about number 10?
Add action listener.
Yep. Add action listener. Why? The reason is that here's the exam 2 ML. So exam 2 ML is action listener. So we want to add the action to our menu item. Right? So I will briefly talk about what it looks like. So it will be like with the menu bar, and then it will have like here's exam 2. It's a menu, and then it has like 3 menu item called like pass, fail, and quick. Right? It will be like this in your GUI if you code it. We don't need to code, right? Okay. Should we do this or should we move on to another question?
Can we try this one since it's short?
Yeah, since it's short. Okay, let's do this. And then we move on. So this one. Okay, so we need to implement the listener. So implement this is like you just need to memorize. This is action listener. So this is like, okay, when I see this is action listener. There's no like logical thing. Right? Then number 2 is okay, you see the mainframe. So where's the mainframe coming from? Mainframe comes from here. So what is F? F is here. What is the data type of the F?
Main window.
All right. So it is all connected. All right. Mainframe. Okay. Where's the mainframe? Mainframe is here, and then F is here. So it needs to be the same data type as F. F is mainframe. So it is mainframe.
No, main window.
Oh, sorry, main window. My bad. Main window. All right. And then number 3. Well, number 3 is like again, you just need to know. So if you implement the action listener, you need to implement this method. The method name is called
Action performed.
action performed. All right. And then the next one, number 4, choose item dot equal. So if this is equal, okay, so this is where you need to read this question. So the question said, if the user choose the menu, pass, message say, hooray, you pass. So you can see here, it print hooray, you pass. So it needs to equal to pass.
Succeed or pass?
No, it need to be pass.
Okay.
Because the question say it's pass. All right. Don't forget this two quotation. Okay, the quotation matters because you are passing that string. All right. Sounds good. Okay, number 5. So when you look at number 5, okay, let's look at the question again. The question said, if the user choose fail, the message saying what? Too bad you fail. So if the chosen item is equal to fail, you need to print too bad you fail. Yes. Okay. You don't need to bold. Alright, so it will need to be too bad you fail. Sounds good. Any question with these two? Nope. Okay. Wait. So let me do another page here. Let me stop sharing for like 1 minute so I can grab the question. I don't want to give the my names and my stuff. I just copy. All right. Then I will put it there.
Do we need to know regex? Regular expressions?
No, you don't need to know rejects. It will be too much to know rejects too. Okay, let's do okay, one question by one question. Okay, let me share it again. Wait, before I share, I need to delete one thing. Like 1 second. All right. Okay, now I can share. Here. You can see the screen. So yeah, this is the exam question. So exactly the same as the review sheet. All right. The only thing that change is it doesn't even have the finally. Right? All the same. So I will do quick. I start with -1. So what do you need to print?
Battery.
Bad array.
Yeah, battery. Right? Because it is index out of bound. Right? Yeah, we already ran over this one, correct. And then this is also exam question. So I don't want to go over this one again. Right, correct. I think you all get it. Okay. Sounds good. So you don't need to like worry too much. Okay. Let me see another question. So so you need to know about like this one. So I will go over a little bit more. So and when you see this, don't trust my answer. Okay. Let me see. Let me figure this out. All right. Let me share again. Do you see the screen?
Yep.
Yeah.
Yeah. So he's going to ask like this. He might be, I don't know, he may be. I don't have the question, right? But like in my test, he was X like this. So you need to know, okay, what is the advantages over the hash map and tree map? Forget about what I wrote here. Okay, forget about like what I wrote here. This is all wrong. It's not good to explain. So just ignore that. So okay, let's talk about that. Let's talk about that. Okay. So hash map over tree map. Okay. So hash map, so let's talk about hash map over tree map. One question. Question one. Right. Hash map over tree map. All right. So hash map is just like a hash map. You already know it has a keys, and then it has a value, right? The values, keys, and stuff like that. And then this is it order or an order? Is a hash map order or not order?
Not an order.
Not an order. It doesn't order. So it just, okay, I want to get this value. So I just get this value. If I iterate the hash map, I will not get like an order value. However, tree map order. Okay. So tree map is like whenever you add it, whenever you add the value, it order by the key. All right. But like it takes some time. It takes rotation. So when you will learn in 313, when you have like a balance tree, when you have like a balance order tree, so it need to rotate. So it has like rotation time. So this is okay. Let me write here. So the hash map order not matter, right? But the tree map order matter, right? So this is the one main difference. And then based on that, based on the question, you need to answer by yourself. Okay, why is it different, and which is better, like in what scenario, or something like that. Okay. All right. So and then so he asks about, you see, advantages over hash map over tree map. Why we show you hash map, and then advantages or using hash map, tree map over hash map. Why we use tree map. Right. So it just say like one or two sentence response. So that is why don't look at my answer. It is too long. So yeah. So the advantages of hash map is faster because it is just O of one time to get the answer. But the tree map is a bit slower, but the advantages is it is sorted. It's already sorted. Right? So this is the tree map advantages, and this is hash map advantages. For one sentence, can I say hash map is a big O of hash map is big O of tree map? I don't understand what hash map is the big O of tree mesh. Because hash map is a constant time and tree map is log time, yes? This is necessary to define tree map and hash map before the comparison. No, you don't need to. You just answer how you understand. There's no one correct answer. All right? Okay. Hash map runtime is, yes, hash map runtime is when you like add to the hash map, it is big O of one. So when you insert, it's big O of one. When you like remove, it is big O of one. This is constant time. Yes, it is correct. And then what is the big O? What's O time? It is so it is like the worst case is log of n because it need to rotate. So as you can see here, yeah. So when you add the one value, right? So you can see this like in the lecture, right? That's not my personal answer. That is all from the lecture. I don't know what lecture it is. I think it will be the last lecture, but like it is from the lecture. All right, this is not my answer. Okay. The runtime big O of log n, because when you add it, it need to sort. It need to sort. It need to sort. And when you remove it, it need to sort again. It's like sorry. When you remove it, you need to rotate the tree. Sounds good with the hash map and tree map. Any question with hash map or tree map? Sounds good.
Yeah, sounds good. Just one question. Do you think he's
Okay.
gonna ask us to create a tree map or a hash map, like write it out, or is it just a English question?
Maybe.
Okay.
So I think what I understand is he will like ask you 3 questions. So the first question, okay, will be like this. The first question will be like this, very similar. The second question will be like this, very similar. The third question like this, very similar,
Mm.
right? But the fourth question, I don't know. He can ask anything.
Okay. Yeah.
So
All right.
he will give you like a average B grade, but like if you want to get like A or something, like good grade, you need to review all of his lecture. So he will ask you if you really study his lecture with the question number 4.
All right.
So
Yeah. All right. Thank you. I got it now.
yep. So I think he is fair because he gives you like 3 questions with his review sheet. But like you also need to do your homework, right? And another thing is
Wait, I have a question. My fault for cutting you off.
okay.
So, out of the two sheets that he gave, which one would you recommend like studying more? The one that you're on right now, the one with the 4 questions?
I like I said, he will ask you, like in my opinion, you need to focus this question. You need to focus this question. You need to focus this question. There are higher chance. I don't say it will be on the test. There's higher chance to be on the test.
Yeah.
But like you need to know everything. Yeah, he could ask this question if he like to, because like these are all like his question, his old question. I mean, like he asks like these question once before in the past. So
Yeah.
he might ask this question. We don't know, but like there's higher chance you will get like linked list, output, like inheritance, trying cache, and stuff like that.
Okay.
Right?
Yeah.
All right. Do you guys understand about the generic GE?
Better if you explain it, advantages and disadvantages.
I think. Wait. Let me see if I have this lecture. Do you guys understand? Wait, who understand the generic? So can you guys answer something so that I know someone is already got the generic?
It's like what is generic, and it's like the definition and the advantages of using generic. How it cuts down time and stuff like that. The time complexity, and why we use it.
I mean, there's no time complexity. Since you're X time complexity, you don't know generic. So that generic is like it is more like a terminology. It is like, okay, we create like let's say we create a class, but the class we already assign class or like a method, but we already assign the data type of the arguments, something like that. Okay. Let me read some chat. It's like when you want to pass a different object data type. Yes. So let me see. Okay, I think this is. Let me share. Since I can share multiple screen, then I can share this too. Um. Can you guys see the screen?
Yeah.
All right. Right. Okay. So look at this example. Okay. So we already know what's list node like class name, but like we usually assign this is string or like this is integer, something like that. However, like we don't want to be like to use one like data type. We want to use with any data type. We want to use with Boolean, we want to use with other data type. So we don't know the data type. So it's like an E. We use E as a placement of like it can be any other data type.
Can it be an object? Sorry for cutting you off.
Yes, I think it can be an object since like object is like it can be at x like a data type. So yeah, it can be also like an object if you have a class. So I can create a listener with this object value, but I don't think he will ask like too much complicated. That is like a little bit advanced to ask you guys. With the advanced, maybe he can ask about like, okay, why we generate, we can use with any other data type. We don't need to write like, okay, generic for, I mean, we don't need to write like, okay, string data type for this list node or integer data type for this list node or something like that. You don't need to be worried about. Just use E. And then if you want to use the generic, you can specify the data type here like this. Right? So it will be very similar to if you have used the like a link like array list or something like that. You should already know how to use it with the like this triangle things. Right? So this is like a generic. So it can be used with the object, any data type. So you can see here. So he used with the SSN. So what is the advantages of the generic? So it's in the lecture. So in this class, the only data type the list can hold is type SSN. However, we can make it general, like object. So this is very general. This open as a runtime exceptions. It can give you so many error and headache. So instead of that, we just use E as a placement. So it's like a generic, it's like a terminology. It's not a data structure. It's not like algorithm or something. It's just yeah, 2 lecture. Wow. 2 lecture in 1 lecture. Wow. Yep. So yep, this is like a generic overview. Any questions for the generic?
So basically the putting the E, for example,
Yeah.
it's basically saying that you could put any sort of object, but once that object is used, it has to be consistent. Whereas the one where we had just saying object, like literally writing an object, that can compare two different objects and that would make the error, right?
You're talking about with this object?
Yeah, like I'm comparing this to the generic on the next slide. So the difference is that the E is basically stating that once you use a specific object, whatever that E is, say it's a string, then it'll be string data, string my data. Or if it was a class appliance, it would be appliance, appliance data, appliance my data, right? Like it would be uniform, right?
I see. So yeah, so like the class will be like this. It will be E. So it will not change this E. It will stay E. But if you want to use it, okay, like let's say this is like linked list too. So it's E. But if you want to use it, you need to specify the data type like in the main method. So it can be string, it can be anything. If you specify here, this E at X like okay, this is I am string data type. So I act as like a string data type.
Got it.
Right. Okay. It pretty much state E as the data type you pass in, yes. So E can be anything as long as you can specify here. So, okay, I will ask you. since I explained like this, what is the advantages of using generic?
You won't have to write a specific object. Like if you just write it once, it will be consistent all throughout.
Yeah. For example, like in your project in the appliance,
Yeah.
since we are using the string data type, okay, what about like we already convert to integer or we convert to something other data type. We need to make another appliance, but we don't want to make another appliance. It is not efficient. So we just use a generic. It's a generic placeholder that can be advantageous. I would say it's not a general. Like I mean, you can say it's a general, but like yeah, general is very broad to say. Yeah, but like it's like universality is too. Um, I don't know about that universality, but like yeah, it's like a general placeholder for like it can be any data type. Yeah. Right.
Thank you very much.
Okay, another question is okay, let me ask you, what is the advantages of using regular expression? So
You don't have to constantly check for specific characters or numbers. You have a general code of what to expect.
yes, you have a general code what to expect. Yes, that is correct. Yeah, so finding the character faster, or like you don't need to check like if you don't use the generic. Let me do we have regular expression lecture? I don't think so, right? Oh, there is. Yeah. Okay. So yeah. So I think he might answer why we should use. Okay, never mind. So yeah. So easy to use and identify the patterns, correct? So let's say okay, let's say for example you want to check the phone, this one, right? So if you don't use regular expression, you need to check with like for loop. Okay, for you need to have like for first you need to check the length, and then you need to check okay every 3 characters you need to have a dash. You need to check with the for loops and other variables. Oh, this one is like okay. So this is very difficult to check with regular for and if statements, since it can be anything before the xqc. So xqc.cuni.edu you can check with a substring, but before that it can be anything. It can be your name. It can be like any email. So regular expression is very good at this because it can say, okay, before this X, it can be any letters and any characters. It doesn't matter how much do you have, but once you see the X, and then you need to be okay. It need to follow by qc.cuni.edu, or maybe X, and then it can be qc or it can be qmail. So you can easily check with the regular expression, and it shorten your code and it improves the readability of your code, right? That is why we use a regular expression. Okay, sounds good. Any
Mike,
question?
Mike, you don't think he'll be asking regular rejects in one of those
I don't know.
questions yet?
It is unpredictable. So um, so he also like he might ask like easy one, but like I don't know because like the last question is you need to know the lecture. That's why you need to know like general understanding.
Okay, so it won't be like it won't be as easy as like asking the advantage of an array list, will it? Because if he does put that, I think it might be possible, at least.
Yeah, it could be, but like yeah, it could be anything because like he already teach you, so he expect you to know these things. So even though you don't know, okay, so many things, if you know, like some of this, like I mean, yeah, some of like 1 or 2 patterns from the lecture, if you understand like this SSN, I think you are more than enough. or if you understand the rejects from our project, you're more than enough because you already know, okay, this is a starting mean, this is like ending mean. The D mean digits, you have 3 digits, and it's 2 digits and 4 digits. And something like that, yeah. Yep. We don't know what is on the test. Yeah. So we just like help you to understand the material so that you will have a good grade in the test. So I just go over this because like this is not on your review sheet. So this could be a good review of like first, why we should use hash map, why you should use tree map, why you should use the rejects, or why you should use the generic. So all right, and then last thing. So please fill out the form, feedback form, because like it can help me to improve the feedback form. It can improve the review section because, as you can see, I just do the breakout rooms because like last time I read the review. So so a student said that some students want to ask questions. Like we just go over one question, and some students ask like another question. So I just like do the breakout room. So as I do breakout room, so if you don't like understand, like small portion of people doesn't understand one thing, like they can go to breakout room and they can like review again, and then so that I can move on. So like it is good for both people. Yeah, because I don't think I can like record the both breakout room. So I don't like want to do like 2 separate breakout rooms and stuff like that. So yeah, and then like okay, please fill out the feedback form. This can help to do the final review session. So if you want to like know, or if you want to do how we should do the review section for the final, leave in the feedback form. Right. All right. Any final questions about the test? In the slide, reasonable rejects for SSI right now. When it return the methods, what is it check-in for doing? I don't see using M. I think there's a typo. I think there's a typo here. No, it's not a typo, sorry. Good question. So it will be like, okay, patterns is the pattern, P, M is a matcher, M. I think what I think is, since we use a matcher, so this matcher recognize what is in the M, and then it matches with this pattern. Right. So I think you just rectangle like this. Yeah. Let me see. Yes, I think it recognized like what is in the matcher. Matcher is like a special special class. So I think it already recognized it. So you just use the M like here when you want to find something. Otherwise, you can just use the thing. Can we find the old question on the queue? So I don't know. We don't have like that with the CS. So just ask your friend. Let me stop the recording.